Imagine this. In the middle of the ocean, a wall of water rises out of nowhere, twice as tall as any ship in its path. A natural phenomenon that shouldn't even exist. And yet, for centuries, it struck fear into the hearts of sailors. Giant waves, also called rogue waves, were long considered sailors' tales, exaggerated stories told by men who spent too much time at sea. But what if these waves were real? What if they revealed more about our relationship with nature than we ever expected? The ocean is full of mysteries. It has always given birth to legends, monsters that swallow ships, fog in which entire fleets vanish, currents that pull everything with them for no reason. But among these stories, one theme appeared again and again. The colossal single wave that emerges from nothing, rolls over a ship, and then disappears without a trace. No storm, no earthquake, no tsunami. Just a sudden, solitary wall of water. Sailors describe them as vertical walls, sometimes 25, 30, even 40 meters high. Scientists dismissed the stories. Mathematically, such waves were considered impossible. Waves in the open sea follow probability patterns. Extreme waves were theoretically possible, but so unlikely that one was more likely to win the lottery than to ever see one. And yet, the reports continued to grow. To understand this, we need to go a step back. Normal ocean waves are like a concert of many voices. Winds blow across the surface, currents carry energy, tides pull on the water. All these forces overlap. Sometimes they amplify each other, sometimes they cancel each other out. Together, they create the typical waves we know, usually between 2 and 6 meters high, depending on the weather. Those alone can be dangerous for ships. But the idea that many small waves could combine by chance into one gigantic wave remained only a theory. Until January 1st, 1995, far out in the North Sea stood the Draupner oil platform. Equipped with the most modern measuring instruments, it recorded something that changed everything. In the middle of normal wave activity, a single wave more than 25 meters high struck. Perfectly documented, irrefutable. The Draupner wave was born, and with it, the confirmation that rogue waves are real. From that moment on, scientists could no longer dismiss the phenomenon. The impossible had happened, not in legend, but in measurable data. Research began to uncover the secret. Rogue waves do not form like tsunamis caused by tectonic shifts. They form through a combination of ocean currents, wind directions, and a type of resonance. Imagine an orchestra in which suddenly all instruments randomly play the same note. The result is a massive, overwhelming sound. The same happens with waves. Energy that should normally spread out concentrates at one point. Some models call it constructive interference, others modulational instability. Complicated terms meaning that the ocean can focus its energy into one single, massive wave. For ships, this is a nightmare. Storms and tsunamis can be predicted with satellites and warning systems. Rogue waves cannot. They form spontaneously and disappear just as quickly. A captain might have seconds to react, often not enough. Many historical ship losses may now have a new explanation. Large freighters that vanished on calm seas without SOS signals and without a trace might have been victims of these waves. Statistics show that thousands of ships have disappeared over the centuries, many due to storms, collisions, or human error. But what if some fell to these unpredictable walls of water? Today, researchers estimate that several thousand rogue waves form worldwide every day. Not all are gigantic, and not all hit ships. But their existence proves they are not rare anomalies. They are a fundamental part of the ocean. They are especially dangerous where strong currents and wind fields collide. For example, off South Africa and along major shipping routes. Exactly there, mysterious disappearances have always occurred. Unlike tsunamis, which create a series of large waves, rogue waves appear alone. One single wave, then everything returns to normal. Some scientists even describe them as a type of soliton, a wave that stabilizes itself instead of breaking apart. Survivors describe the experience as almost supernatural, a wall that suddenly darkens the sky. The ship lifted like a toy, then dropped into a deep valley of water. Metal crunches under the force. Windows shatter like glass beads. Some even describe an eye in the water as if the wave were alive. Of course, that's poetic. But it shows how deeply this phenomenon affects the human mind. Modern technology tries to provide protection. Satellites scan the oceans, sensor buoys detect unusual movements, algorithms calculate probabilities. But absolute safety does not exist. A container ship hundreds of meters long can be thrown off balance within seconds. Even giant cruise ships have suffered damage. Windows on upper decks shattered when mountains of water taller than 10 stories crashed into them. This leads to a deeper question. What do these waves tell us about the relationship between humans and nature? For centuries, we believed we could control the ocean. With bigger ships, stronger engines, better navigation, but maybe rogue waves remind us that nature still holds surprises far beyond our calculations. They symbolize the unpredictable, the uncontrollable. Even in culture, they have left their mark. Painters like Hokusai depicted waves as monstrous crests swallowing boats. Poets describe them as the ocean's fury. Films and documentaries use them as symbols of overwhelming power. They represent an archetype, a sudden, unstoppable force that changes everything. Maybe that's why rogue waves fascinate us so deeply. They remind us of our own fragility. Interesting, too, is how science and myth merge here. What was long considered sailors' imagination is now a measurable phenomenon. And yet, it remains mysterious enough to fuel our imagination. This tension is what makes the topic so unique. We can calculate it, but we cannot control it. We know it exists, but we don't know when or where it will strike. And now the final question. Why does this matter today? Because our world is becoming more dependent on the oceans than ever before.